So this is the Surveyor 3 craft as it was sitting on the moon taking photos of its footprint, his foot pad, right? So I want to explain this series of photographs. In the first photograph on the left, the scooper has scooped up one scoopful of dirt and dropped it onto the foot pad. So that's photograph number 1 on the left. Photograph number 2 in the middle, the scooper has scooped up many different scoops and dropped them all on the foot pad. So you can see the foot pad in photograph number 2 is nearly halfway covered with dirt. Now, photograph number 3 on the right, what has happened is the scooper has taken the tip edge, come back down to the foot pad and pushed away some of the dirt. You can see there's a white spot in the top, on the top of the foot pad where the scooper had scraped off some of the dirt. All right, so this is the real Surveyor 3 craft, which is still sitting on the moon today. And this is the way it should look today, because this was the final movements of the scooper and the final photographs sent to Earth. Now, I'm showing the reference. This is the document where these images came from. Surveyor 3 Mission Report, Part 3, Television Data. All right, let's look at these images. All right, so here you can see the footprint, and here you can see the clop of dirt and where the scooper has pushed away some of that dirt. So you can see a very clear white spot here where the scooper pushed away some of that dirt. Next image, the same thing, but it's a little bit higher up, but you can see you can see where the scooper has pushed away some of this dirt, right? Okay. Next image, same thing. This is one of the final images of the scooper, the foot pad, and where the scooper has pushed away some of the dirt. Yes, I think you all can see that. And final image. There's 4 images of the final resting place of Surveyor 3. There's 4 images of the final resting place of the final foot pad after the scooper has pushed away some of those dirt that had been dropped on the top of the foot pad. Now we come to Apollo 12. Oh my goodness. So on Apollo 12, it's not the same. Sorry, it's not the same dirt. They tried their best to kind of imitate the dirt which had been dropped on the foot pad and then scooped off, but you can clearly see it's totally different set of dirt there on the foot pad. Okay, and like for example, even here, this is a different point, but the footprints here, the craft supposedly bounced, and it bounced once and then bounced twice and then bounced a third time. This is also impossible, but we're not going to go into that point today. Let's just keep looking at the dirt on the foot pad. I'm zooming in on this dirt. It's totally different from the actual Surveyor 3 craft. You can see the dirt is still there in the middle of the thing. Okay, let's keep looking more. So there it is. Now the astronaut put his boot to hide the footprints. You know, he put his boot down to kick up dirt and hide the craft's landing footprints. But you can still see, you know, I'm zooming in on this dirt here on the foot pad. Next picture, same thing. Now, in the next picture, he goes to the other side of the craft. Now, when he gets to the other side of the craft, he purposely leaves the camera out of focus because he knows that the dirt on the foot pad is not the same. So you can see the camera is purposely left out of focus here. Not only is the dirt on the foot pad not the same, but these scoop marks. They tried to emulate the scoop marks from the real Surveyor 3 craft, but if you actually analyze the real scoop marks, you'll see these are different scoop marks, but we're not going to go into that point. Now we're just focusing just on the footpad. So you can see, even though it's out of focus, you can see the clumps of dirt here do not match at all. It doesn't match the Surveyor 3 craft. So let's look at a couple more. Here's again, you can see the dirt there's dirt on both sides, and there's no white spot in the middle like on the real Surveyor 3. Next one, same thing. Oh, this is the best one, really. You can see it's totally different dirt. All right, last one. I think this is the last one. Yep. You can see the dirt is different. All right, so this is my final image. The top two images is the real Surveyor 3 craft. I zoomed in here on the dirt. You can see where the Surveyor 3 dumped the dirt and then it scooped away some of that, and it's white here where it's pushed away. And again, this is zoomed in. The scooper pushed away some of that dirt, and you come back down here to the Apollo crafts. It's totally different. It's totally different.
Yeah. So they were two drastically different daytimes, right? So the photos from Surveyor 3 looked like they were taken where the sun was coming from above. There weren't any side to side shadows. The pictures from when Apollo 12 was there, the sun was shining from the side, and so specifically it was coming from the front of the foot. So the part where it was scraped was in shadow in that view there.
So this is a clip from the original Spacecraft Films DVD, which shows the flag waving even though there's nobody around it. And this clip has been edited. NASA tried to hide the flag waving, but we can get the original film from Spacecraft Films DVDs. And so I just want to show you this flag waving even though there's nobody around, and explain how the official excuse they're giving is bogus. Right hand corner, top corner, you see the flag just blew onto the set. Okay. And it's kind of a waving there. And then it blows away. So now the official story is that there's some exhaust gases, but then it kind of blows back onto the set again, which cannot happen in a vacuum. It cannot be sucked back into the craft. So it's definitely moving with the wind here.
I don't know if it was just me. I don't know. It was so hard to see. Could you point to with your cursor, like what we were supposed to see? It was hard for me. I'm 72. I don't know how old you are. I can't see with these old eyes. Go ahead, tell me.
Here, can you see on the? Let me rewind it.
Yeah,
okay?
we can see your cursor. We can see your
Yeah.
cursor.
So just watch here in the upper right-hand corner.
Okay.
See the flag?
Yes.
Yes. There, and it blows on the stage. It blows off the stage 4 times. It blows on, blows off, blows on, blows off. Now the official story for this is that the LEM is emitting exhaust gases, and that the flag somehow falls back down due to gravity, but that is not possible, because if that was gravity, that would mean the resting place for the flag is on stage, and it blows off and gravity pulls it back down. But that's not it where it is. The resting place for the flag is off stage, and it's the wind that blows it on stage.
Okay.
So that's my second proof of a hoax.
MC Toon, are you ready to throw in the towel?
No, air starts blowing. and it blows it like this temporarily, not air, gases, exhaust from the limb, and then it stops. And what happens when the gases stop blowing? It goes back to where it was before because there's a rigid rod holding it there.
Sorry, that wouldn't work because that would mean if it blew it away, it would return after a certain amount of time. It basically comes back to the gravity excuse. This is not the original resting place is off screen. It cannot be blown towards the ship.
How do you know that the original resting place is off screen?
Because it's a 20-minute video and only a few minutes of it is on screen. The rest of the 20 minutes is off screen. That means the resting place is off screen, not on screen. If the resting place was on screen, then there would be 20 minutes with flag and then it blows off.
So the fan is your assertion the fan in the studio was on or off for the bulk of the 20 minutes? It's so ridiculous saying it. Off. And so only
off.
when the fan is on is the flag on screen?
Right. Correct.
This fan in a studio that people don't actually do. They don't actually put giant fans in studios.
With that, we're going to kick it over to MC Toon. Thanks for being with us. The floor is all yours for your opening statement.
So Apollo landed on the moon, and in 1969, some people recorded it live as the actual broadcasts were sent from the moon. Particularly Larry Basinger in Kentucky did this. There's the antenna that he built. He bought a World War II era radio and custom built that antenna, and he put it on a motorized alt-az mount and recorded the audio from the moon. They pointed that antenna at the moon and heard the astronauts before it was broadcast on TV. When they were not pointing the antenna at the moon, they didn't get the signal. And when the moon set, they didn't get the signal. But they did get 35 minutes of recording while they were pointing it at the moon. There is no orbital satellite. There is no way that you can put something in orbit around the Earth to transmit from between a particular viewer and the moon for that amount of time.
All right, so you can see that the command module had a FM signal of 2272.5 megahertz. And the SIVB had a FM signal of 2277.5 megahertz. So the way they faked the moon landing was the SIVB was the unmanned craft which they sent around the moon, which was transmitting at 2272. So the public thought they would tune into 2272 and tune into the command module, but actually they were tuning into the SIVB, which was just an unmanned craft circling the moon. The command module itself remained in low orbit the whole time.
And we're going to kick it over to MC Toon for his opening statement now as well.
We've got the video right here. It's a really short video of it falling here. And I know, James, you don't want me to play the audio. This is from NASA, so it is in the public domain. But they dropped the hammer and feather, and this was broadcast live. Right there it is. Broadcast live to TV. And so they did fall at the same rate. So they had to be in a low pressure environment. So could it be a vacuum chamber on Earth? Well, if it were in a vacuum chamber on Earth, then we could test for that by looking at how fast it accelerates on the Earth. But let's just measure it, right? So the frame rate of the video is 29.97, about 30 frames per second. How many frames did it take to fall? And we can count that. There we go. This is my own video. I edited here and I counted the frames by hand as it falls. And after we do this, knowing the frame rate, we can apply kinematic equations to determine how much acceleration it was experiencing. So there you go, 36 frames, and that's 1.2 seconds. And the height of the drop was, let me go back. The height of the drop was about 4 feet. So here's kinematic equations. We can use number 3 because we have the displacement, the time, and the initial velocity of 0. We can substitute that in, that v sub 0 times t plus 1/2 a t squared gives us x. And we want to solve for acceleration. I'm doing this quickly here. But you see on the bottom left there, acceleration equals 2x over t squared. Plug in those variables, that gives us 1.69 meters per second squared. I missed the squared in this slide here. The acceleration of the surface of the Earth is 9.8 meters per second squared. And what is the expected acceleration on the surface of the moon? Well, it is 1.63 meters per second squared. So this confirms that it is falling in moon gravity, and it confirms that it is in a vacuum chamber. So sweet. We've confirmed that. This was live broadcast on TV. And could it have been something else? Well, let's see here. Conclusion, the hammer and feather demonstration must have taken place in a vacuum and at a rate of downward acceleration of the moon's magnitude. There you go. But could they have been in a vacuum chamber and recorded normally, then slowed down to make the drop time match moon gravity? You know, like on the surface of the Earth somewhere and then in a gigantic vacuum chamber. Well, there wouldn't be enough frames in the final video. But what if they recorded at a faster rate and then slowed it down? You know, changed it. What FPS rate, frames per second, would they need? I do a little math here. On Earth, the fall should take 0.49. Say it was sped up. This is what the actual recording was according to them, and what it looked like when they actually recorded it. So here we go. The audio, I'm going to leave the audio because you hear how fast it is. Look, watch how they move around and bounce, how fast this is the claim that this was how it looked when they actually recorded it in real time. So watch them bounce around way too fast. Boingy, boingy, boingy. Not how people move in reality. So it could not have been sped up in real bulky suits and stuff like that on the surface of the Earth.
The first one is that you're basing it on several assumptions. One assumption is that the frame rate is 29.7 frames per second, which of course it wasn't. And you know, you can't just take NASA's word for it. It's not science if it's based on other people's word.
I didn't take anybody's, I measured the frame rate myself.
Yeah, but you were told by NASA that it was filmed at 29.7 frames per second.
No,
You're taking that
video,
for granted.
No, the video that I have is 29 frames per second. I know that NASA did not transmit it at 29 frames per second, but the video that I have is at 29 frames per second. That's how I measured the number of frames. Because I went into I have the program called VLC. It's free to download. And then I put that video that I downloaded from the YouTube channel in VLC, and I went to media information, and it said frame rate 29.97. That's how I know.
Wow, so you're just taking the person who created the frame rate. Okay, anyway, you're just, so the second point is that, the second assumption.
Okay, yeah, go ahead.
The second assumption is that this was being broadcast live, which it was not. It was being played back. And the third assumption is that this had to be filmed in a vacuum chamber. No, it didn't. The only thing they had to do was take a feather, put lead in the feather, it will drop the same as a hammer. You don't need to be in a vacuum chamber to have a feather drop the same as a hammer. So these assumptions are totally wrong. You don't know what the frame rate is, you don't know that it was broadcast live, and you don't know that it wasn't a weighted feather.
I do know that it was broadcast live because millions of people watched it live.
Okay, billions of people saw it, so that means it was true.
No, that means it was broadcast live. Millions of people watched it live. That's how we know it was
You
broadcast
don't know
live.
what you were seeing, whether it was live or not.
But I did do analysis of it, and I did confirm that the gravity there was not
gravity.
Earth gravity.
The gravity
You
is based on the frame rate,
You didn't
which you're
address that.
assuming.
No,
You're
I didn't
assuming.
assume it. I
You're
didn't assume
assuming
the
the
frame
frame
rate.
rate.
I read the frame rate off the metadata in the video.
The metadata was created by NASA. You're just
No,
taking
it
their
wasn't.
word for it.
The
Yes, it
metadata,
was.
the metadata was created by the video editing program that digitized the video.
Yeah, which is
You
NASA.
don't understand. No, NASA didn't digitize the video that uploaded to YouTube.
All right, the next point is this.
No, you didn't address this.
Your
We
point
can-
is
we
so
can
based
time
on
how-
assumptions.
We timed how long it took. The frame rate is irrelevant. I know the source
Totally
is not the source.
irrelevant. You can't calculate gravity without frame rate. It's the most
Yeah.
important thing.
Yeah, here's what you could see. If you watch the 36 frames that I did, you can see that not every single of those 36 frames is the actual source video updating. The source video transmit live in 19 which was 71, right? Was definitely not 30. It was slower. I think it was 11 or 15 or something. I don't remember the exact. So but so you can see that, and you can see that 2 frames in a row don't move the hammer, and then it moves, and then 2 frames in a row it doesn't move, and then 1 frame and it moves, and then 2 frames and it doesn't move. Right? That's what when you move frame rates from one rate to another, it just keeps the same frames consistent. So the original, yes, definitely not 30 frames per second, but the source video that I have was 30 frames a second, and that tells us how long it took. And it took 1.2 seconds for it to fall. So then I sped it up to the rate that it would be on Earth, about double. And then played it, and we watched. And so this is what, I didn't take NASA's word for it. I played it at the rate that you would need it to be at for it to have been accelerating downward at the rate that was on the surface of the Earth. And then they look ridiculous. It's obviously not how they're walking around.
Okay, let me reply to that. So if you watch the NASA video carefully, what they did was they have it playing back at one speed, and just before he drops the hammer, they change the speed. So that way, yes, of course it will look ridiculous if you play the whole thing at the right speed. But if you see only the feather hammer drop, so this is actually very simple. They
Just a
did
second.
this on.
Just a second. You don't trust NASA. I definitely don't trust you. So do you have proof of this, please?
Okay, so in what is this, the movie Capricorn 1, and on that movie, he's jumping down from the ship, and the guys in the control theater, get ready, he's going to jump, slow down the film, and then they slow down. Of course, this is just but this is so easy for them to speed up and slow down wherever they want.
Okay.